Hello and welcome to another session where we are going to talk about a grade 10 math. We're using IXL to have some examples to talk about, explore that further if you want to. It is one of the handy websites for sure. We're going to talk today about some radical expressions, just an introduction. So we'll simplify some radical expressions. Now, let's wait for this guy to load. Remember, just as we start our first one, remember what the square root represents. If I have some mystery number squared equaling, let's say, let's say 8. Well, let's make it simpler, perhaps. Let's make it a 4 or something. Then we want to be able to write the answer. What is this mystery number? And the square root is simply a mathematical word, a mathematical symbol to do exactly that. And we'll say that that mystery number is called the square root of 4. Now, things are, in general, a little bit more complicated, that it could be a plus or a minus and so on. I don't want to really worry about that right now. Just remember what the square root is saying. What the square root is saying. Okay, so it's a way to reverse the square. So if well, we'll worry about that as it comes up. Like right now, I have some basic square roots. So just like when I had a times b to the power of something, I could or I can expand that to a to the power, that same power, times b to that power. A very similar property that if I have, and we'll get to how we use that for these examples, a times b inside a square root, I can write that as the square root of a times the square root of b. As long as they exist and they're all positive, I have to have some positive numbers there because I cannot calculate the square root of a negative number. If I say something squared is -1, well, there's no real number that I can plug in here that would, when I multiply it by itself, give me a negative number. So the square root has to be, I have to have a positive number inside. So as long as I do that, as long as I have that, then I can split up the square root exactly the same way. It is really an extension of this exponential property. So when we combine this guy with the fact that the square root simply reverses what the square to the power of 2 exponent does, we can also combine that if I have any number to the power of 2 and I take the square root, well, the square root reverses what this does exactly, and I'm going to get the number back. Now, there are some more general complications here, but for now, I don't want to get into that. I am aware of that in case someone else watches this, uh, but I don't want to worry about that right now. So how do we combine these two things? Let's just make some space. Now I'm going to write my square root of 8 as, well, first I'm going inside the square root. I'm going to split this up as 4 times 2. Why do I do that? Because I know that 4 is a perfect square. You can also write it as 2 squared times 2. That is a weird 2. Let's try and fix that. 2. There we go. Now I'll use my property. And again, I'm making this seem perhaps more complicated than it needs to be because it's just an 8 inside. But if I understand how the square root works and its properties, then I don't have anything to do when I head into algebra because all these properties are exactly the same. But many people look at algebra eventually when I just have letters and things and variables and expressions, no numbers inside, that I have to do something different and weird, but it's the same properties. So now I'm going to split this up with my extended, that is not a 3. I don't know why it keeps making a little tail there. Split that up with my extended exponent property, really. This will be a 2, and that will be root 2. So let's write that in here. I'm going to write 2. Now there's no dot in this case. I guess we could just do that so that it's happy with how we're writing this. We got it. All right. So now we're just practicing that again. Oops, I want to write. There we go. So I need to split square root of 20. I need to split the 20 up into a perfect square. I can also just write 4 times 5. Make sure your square root extends all the way. That'll then become square root of 4 times square root of 5. I don't need to write 2 squared. As long as I recognize it as a perfect square, I can write 2 root 5. And the fact that I have a symbol here allows me to not write a dot or a times symbol in between. The multiplication is implied if I have nothing in between it in this case. Now, root 5 cannot be simplified to an integer or a fraction. A root of a prime number is what we call an irrational number, a non-repeating, non-terminating decimal number. So that's as far as my simplification can go. And I have 2 root 5. Very important skills as we, or understanding and knowledge as we go into algebra slowly. All these properties are exactly the same. So now I'm going to look, I need to factor this 50, but in a specific way so that I can simplify the square root. So I'm going to go 25 and 2, extend my square root so it's nice and clear what is inside and what is outside. And then I can go root 25 times root 2, and this is therefore 5 root 2. Notice how we write the number in front of the square root, so that if you write like this, sometimes people don't have their square root very clear where it stops, and it could easily be misread as a 25 inside, which is of course not correct, or their dot is in a weird place, something like that. So it's a little bit easier to read if you put the square root at the end. Let's put that in and see if there's any variation to this question here. Root 2. Wonderful. All right. One more, I suppose. Just practice is all we need. So I'm looking for a perfect square. So right now I'm already thinking, well, 9 times 3. I can write it like that. Sure, it's finished to have the 9 times 3 inside. So then I have root 9 times root 3. I chose that because 9 is a perfect square. 3 times 3. And so we can simplify root 27 as 3 root 3. I'll leave this one for you to practice as well as more on whatever platform you might be working with. And we'll end our introduction over here. Hope you have a great day. Let me know in the comments what the answer is to this. What do you think is the answer to this? Let me know in the comments, and I will see you next time.
Welcome to MathCats, where we aim to better understand mathematics. Join us weekly for discussions on elementary, high school, through to university math. You can request the next topic by leaving a comment on our YouTube channel or by emailing us at mathcats314@gmail.com. And as always, remember to like and subscribe. Thank you.